In this video, we're taking a look at simplifying algebraic expressions. When we're doing that, we're really talking about how to use the properties of algebra and, in essence, aka combining like terms. So going back to some ideas that we've already explored, but taking a little bit further, if we look at these three expressions, recall it's an expression because there's no equal sign at the end. So when looking at this expression, if we need to simplify this expression, we're looking to see, are there any like terms? Terms are things that you add and subtract. This is 18x squared, this is 7x, this is negative 3. Or another way of thinking about this is 18x squareds, this is 7x's, and this is negative 3 whole numbers. Since each of them are representing three different items, this is x squareds, that's x's, these are whole numbers, there is nothing that we have that's in common, so that is a completely simplified set. Go to the next one. 18x squared, 7x squared, negative 3x. Now we have these two terms that are both counting how many x squareds we have. So for a grand total of 25 x squareds, and then we have minus 3x. When they are separated like that, x squareds and x, they are very different items. X squared is not the same as x, so they cannot combine when adding and subtracting. Finally here, now we have all three of these. We have 18x squareds, we have 7x squareds, we have negative 3x squareds for a grand total of 22 x squareds. All right, in this case, then they're all counting how many x squareds that we have. Moving on to this next step now is when we start doing some algebraic properties first. So when we see these parentheses, parentheses mean multiply. So we're going to take this and we're going to multiply this 6 into each item here, yielding a total of 6x squared minus 12. Can I simplify that even more? And the answer is no, since they are different types of terms. That's x squareds, those are whole numbers. Moving into the next one, you see that starts with the same part, so 6x squared minus 12, then we have plus 5. Now we do have common terms, so we have 6x squared minus 7. And then the last one here, we're starting with something similar again. So we're going to start, however, by looking and saying, well, now I have to remember all those order of operations. And in doing so, we look to see what do we have to do first. Multiplying comes before adding and subtracting. And it's now a negative 6 in front, so I have 4 minus 6x squared. Now it's plus 12 because I have that negative 6 times negative 2, then plus 5. And then when you combine all these terms, my final answer is 6x squared, and then I have 4 plus 12 is 16 plus 5 is 21. When dealing with fractions, much like we've done in the past, when we have common factors, something that can divide into both of these, in this case, the number 4 can divide into both of them. So this number, both are divisible by 4. This is the same, we could rewrite it as 4 times 1 and 4 times 2. The 4 divided by 4, leaving me with 1/2. Here we have 4 times x over 4 times 2. And again, multiplying and dividing are inverse operations. So if I'm only multiplying and only dividing, that's when I can reduce. 4 divided by 4 is 1, leaving me with x over 2. Another way to write that would be 1/2 x. I prefer this way because oftentimes this can be accidentally written with the 2 looking like it's in the denominator. people get sloppy and they might write 1 over 2x, and that would be a very wrong answer. Even though you might think this looks the same as this, they are not. This has an implied fraction bar that goes over the top. And then that would be a very, like I said, a very wrong answer to what's going on there. So how you write things does matter. Pay attention to especially fractions. And then when doing fractions, only use horizontal fraction bars. If you've been in the habit of doing something, we'll like do a little sidebar over here, of writing 1/2 as 1 over 2, you need to stop doing that. You need to now write it as 1 over 2 with a horizontal fraction bar. Here we have two different fractions going on, but now we have adding going on, so I have both terms and factors. In order to do something with terms and factors, I need to see if there's a way I can rewrite something in the top as the multiplication of two items, and the answer is yes, I can. Reverse distributive property. I pull a 2 out of each of those, and now I have 2 times 2x plus 1. So if you didn't quite see that, taking a 2 out of the 4, dividing it out in front, taking a 2 out of the 2, dividing it out in front. And if I distribute this back out, it'd be 2 times 2x, which is 4x, 2 times 1, which is 2. It would be the same thing. In the denominator, I have 2 times 4. And then from that, I can see that those 2's will reduce. 2 divided by 2 is 1, leaving me with 2x plus 1 over 4. And that is a final answer. There might be some of you who might want to try to take this 4 and divide a 2 out, but when we have mixed operations, we have adding in the numerator. It's not just multiply and divide. I can't do inverse operations of multiply and divide unless both terms have something. And so then that's what I have down here as well. 4x plus 1 all over 8. That is a final answer because there is not a single number that can divide into all three terms, 4x, 1, and 8. Lastly, working here, this is already divided out for us. Had this been an original equation, it might have been 4x minus 8 over 18x, and then reverse distributive property. But what I have now is I have this numerator and denominator both divisible by 2. So I'm going to rewrite this as 2 times 2 times x minus 2 in the denominator, 2 times 9 times x, reduce, reduce, leaving me with a final answer of 2 times x minus 2 all over 9x, and then I could actually distribute that out and have 2x minus 4 all over 9x. When I look at those three items, 2, 4, and 9, nothing is divisible in all three of them. This is x's, that's whole numbers, this is x's, they all aren't counting the same thing. So again, nothing else that I can take out of there. That's your quick background and reminder and refresher on simplifying equations.